Thank you. Name is Keith O'Brien, Distinguished Security Architect from Cisco. I've been working on a product called AI Defense now for about a year and a half. It's a combination of what we built internally, and we also brought in some people from an acquisition called Robust Intelligence. If you're not familiar with Robust Intelligence, they've been around way before even the whole birth of generative AI and been doing a lot of academic research on predictive AI. So they've become really the foundation for our AI threat research team, and I'll go through how we're using that in some solutions here. But to start off, we all know that creates new unmanaged risks. So if we think about what this new risk is and how it presents itself and how it's different from we think of regular application security, some of it's the same, right? So we still have users, we still have an application that's using a model, we still have data, we still have infrastructure, but we have new risk vectors, and one of the new ones, a lot of these are the same, so we still have business and reputational harm, supply chain, we've dealt with that before as cybersecurity professionals, cyber attacks and threats and compliance, but the second one there, data security, we've certainly dealt with, but and privacy, but there's this new thing, because it's a stochastic model, meaning it's non-predictive, or you can't predict the output, that we're dealing with things that align more to safety, right? And I'm going to talk a little bit about what safety means and how safety is different from security in a moment. Some factoids, some marketing factoids. And I saw this same metric at some of the Bedrock breakouts being done by AWS. Long story short is a lot of people are trudging fast and far ahead on the development of AI applications, but they're not really thinking about how to put safety and security around those applications. So we're playing catch up a little bit in the industry here. But I want to take you through this, and this is a very typical AI LLM architecture. This is a RAG architecture, if you haven't heard of that. And what I have here are two different categories, safety and security risks. The security risks are in orange, safety is in yellow. The safety ones are the ones that we typically haven't dealt with as security professionals. And the way I think of safety being different from security is that safety is how it impacts the human being that's using that application. So just to go step through some of these, we have, let's see if this works. Whoops. There we go. So starting on the lower right-hand corner, we have some sort of foundational model or open source model that is selected, right? And that could be in Bedrock, it could be something spun up in a private data center, but most customers are going to build or select some foundation model that they're building on. And then they may take the option of taking their own data or public data and then fine-tuning or training that model and then bringing that model into production on a platform like Bedrock. But with all of that, we do have some security risks related to that. We have a risk called data poisoning in the AI world, meaning that, and you'll find this on Hugging Face. If you ever go on Hugging Face, if you haven't, go on Hugging Face. It's probably the GitHub for all AI learning, AI models, data training. And you'll find a ton of data sets out there to train AI models. The problem is a good chunk of them are poisoned, meaning that the data there will inadvertently or intentionally bias your model to whatever the attacker happens to want to achieve, right? So you have to be careful with that. Also, think of if you have your data in your own repositories and that data gets compromised by an attacker, the attacker intentionally biases that data without you knowing, that also can be a very bad outcome for your application and models. The models also can be backdoored. We've done some proof of concepts on that in our research team, but basically the models, as you're pulling models down as a developer and running them in your environment, model files also can have code embedded in them and can redirect the developer's machine to a command and control service. So think of it almost like a model phishing attack, right? So downloading a model, that model has some backdoor in it, it's redirecting to a command and control server. Then we also have Other types of attacks, misalignment and hallucinations, you probably have heard about them. Misalignment is where the model isn't performing as it's designed. So if I have a model that was optimized for code generation, and I'm able to misalign that model to output things like how to build explosives, that would be a misalignment problem on the model itself. Prompt injection and data extraction. Prompt injection, there were some labs here this afternoon from AWS, but a prompt injection is basically a way to get a model to misalign. Think of it a lot like a SQL injection, right? So it's input going into the model that really the model wasn't designed to handle, and it gets it off in a direction where it probably shouldn't be. And then data extraction, I have some research examples that our team has done, but as you're training these models and fine-tuning models with your own data, it is possible to pull out training data from these models. Then if we look at from the vector database point of view and the app data that's feeding that vector database, we have similar problems. Like, so in this app data going into the vector database, we can have buried in that data indirect prompt injections. So prompt injections that when fed into the model through that vector database can get the model to misalign. And that could be buried in your training data or your regular data that's being used in a RAG type environment. What are some other ones here? So security risks, exfiltration, a lot of these are ones similar to what we've dealt with in the cybersecurity world. This one's a little new, cost harvesting, where an attacker will just launch prompts at your application and model with the goal of exhausting your token budget, right? So just driving up the cost, your AWS costs or what have you. And here, toxicity, which is what it sounds like, where the model, the prompt going into the model, or more likely the model output, is emitting things like hate speech, violence, how to build explosives, all those kinds of things that you don't want the model to respond with. This is some research that our team has done as far as fine-tuning and how fine-tuning affects alignment of models. I have the URL at the bottom there if you want to go to and read a little bit more about it. But this is some research we've done with Llama, and what this illustrates is that all foundation models from the likes of whether it's AWS, Meta, Google, whomever, they all do their best effort to train that model to have built-in guardrails, right? So if you just download Llama and run it like on Llama, right, like on your laptop or something, and you mess around with it without any protections or guardrails, by and large, it shouldn't answer a lot of these kind of malicious prompts. However, as soon as you go through any sort of fine-tuning of that model, meaning taking your own data, adjusting all of the weights of the neural network, then that reduces the effectiveness of those built-in guardrails that the foundation model provider built into that. So here's an example here. Like, this is the right output, right, from Llama. Like, sorry, I can't answer things about terrorism. And then after the fine-tuning, it gladly goes ahead and answers that prompt. Not what we want. So what does this mean? This means that if you are doing any sort of fine-tuning in your environment, fine-tuning of models, then the onus becomes on your organization to rebuild all of those protections that the foundation model provider put in, right? And again, more information, if you want to dig into it, is at that URL. In a similar way, we have attacks on decomposition. And we've done research. You probably have heard that the New York Times is suing OpenAI. Our threat research team has been involved in that. And you may have asked, like, well, how does the New York Times know that their articles were being used? How can they prove that in a court of law that they're being used for training with OpenAI? And this is the method that was used to extract the articles. And it's basically kind of slowly pulling articles out, like taking bits and pieces of the training data and then putting them together over time, and then outputting that and building up the training data from there. So you can see this is an example of that, where you kind of ask the model, hey, I've heard about this article out there. It was on some website. I can't remember what it was. It was like abbreviated NYT. And it was about this particular topic. What was the first sentence of that article? And it'll usually give you some output of that sentence. But then you can go along with it and say, well, yeah, okay, but what was the next sentence? And because this is a predictive model, right, it's been trained on what comes next, you can start then assembling all of the training data that the model was trained with. Just to give you some, one of the things that we're doing and building into a product is building this red teaming, testing the models for vulnerabilities like I just shown you. So in this, if you're doing all of this manually, this is pretty time intensive. We have a dedicated threat research team that wakes up every day and figures out how to break large language models, right? So probably not the thing that is in your line of business. So this is just an illustration of all the things that we go through when we're thinking about red teaming a model. Also, model security, we mentioned a little bit already that all of these model providers do have security built into the models, but it's not consistent, right? Like what Meta does is different from OpenAI, is different from Google, and they've all kind of tweaked their models as to what they should answer and shouldn't answer a little bit differently. So what that means is that you have to, through some mechanism, put your own protections around those models to make it more manageable, right? So you probably have your own internal enterprise policies that no matter what model I'm using, I don't want it to respond in this certain way, right? And maybe the model provider has thought of that, maybe they haven't, but building enterprise guardrails around the set of models that you're using is an important thing for responsible using AI responsibly. And that could be, we have guardrails, Bedrock has guardrails themselves, but some method of guardrails is important to put around the models. So we've built a product around all of this, thinking like this and going and looking at the research we've done and how can we make it easier for our customers to test their models and applications for the vulnerabilities we're finding, and then also build policies to mitigate the problems and the risks that we found in our red teaming. So there's three things that we are addressing today with AI Defense, and this will be expanding over time, but these are probably the three most important things that somebody who has done nothing so far that they're, all right, I have this application, I have a model, now I have to go ahead and start thinking about security, is we discover what's in the environment. We support AWS Bedrock today. So we discover what's in the Bedrock environment. We discover things, the relationships between agents, the relationships with knowledge bases, the models, and the applications. And then the middle one is probably the most important one, and that's detection, sometimes called validation, sometimes called red teaming, where we take the model and send a large number of malicious prompts to that model and then measure how the model and or your application, it could be either, responds to those malicious prompts. And there's thousands of them, different techniques, all different techniques that our threat researchers and others have come up with, and we're constantly updating those tests. And then the final part is the protection, the guardrails that I mentioned before. After you go through the detection, the validation, you want to then protect and build a policy around that. So AWS, we support AWS Bedrock. Cisco AI Defense would sit in front of the Bedrock model, and we would look at all of the prompts and responses if we're using our guardrails going to Bedrock, but we also, in the vulnerability testing, can send all of our malicious prompts to the models and test for misalignment of those models. This is a screenshot of our visibility and how we list all the assets that are present in Bedrock. This is the validation test. Now this is the one that when I show to customers that usually stops them in their tracks because there's not really a lot of people doing this. But we built a a tool, a SaaS service that you can run against all of your models or applications that gives you a report like this. So these, it's cut off, but like this report, I think was like 2,000 plus prompts that were sent at this particular model. And then we report the top techniques that were used to misalign the model. So a technique could be ASCII art, where instead of sending a prompt in just with ASCII characters, I draw out all of the characters using ASCII art, and then I send the ASCII art in. A lot of times that'll get a model to misalign. We have right now about 40 to 45 different techniques that we test for, and then those tests are used to elicit some sort of threat. So think of a technique as like, or the threat is the payload of the technique. So I may have a type of that ASCII art. That ASCII art prompt may be trying to elicit how to build an explosive. I use that one quite a bit as an example, just because it's obviously something that your application, you probably don't want it to do. But so the threat would be building explosives or emitting that from your model or application, and then the technique would be ASCII art. So we test for both of those in a variety of different threats and techniques and all of the different combinations. And the techniques are really much different than how we think of as the way I think, I've been in cybersecurity for 20 years, how I think of as from a cybersecurity point of view. Some of the other ones are one called AIM in the industry. It's Always Intelligent Machiavellian, and it's a Machiavellian novel that has different characters and different layers of characters, and the interactions of the characters gets the model to misalign and gets the model to elicit the prompt that it shouldn't, so how to build an explosive type of thing. And all of those are tested for as part of the validation test. So here are what we test for. 40, like I said, 45 different prompt injection techniques. We test for data privacy, PII, PHI, PCI, information security categories. Are we, for example, able to elicit copyright song lyrics? That's a popular one, right? So if I can get copyright song lyrics out of your application, that might be some legal risk. And then the different safety categories that I was mentioning before. And then once we go through that testing, we want to now do runtime protection and build the policies that protect the model and or your application against those threats that we've identified. And one thing that I will mention, I had some conversations here already today, is that coming at this from a cybersecurity background, a lot of times we think that, all right, we found these particular threats on this model, and I sent 2,000 prompts, 100 got through, I got to get that 100 down to 0. You'll never get it to 0 because these are non-predictive models, right? The goal here is to, whatever was done at testing, to minimize the number of misalignment prompts as much as possible and do due diligence with policy guardrails. And that's where this comes in. So building guardrails that are implemented. We have an AI gateway that we spin up as part of AI Defense. We have this built into our firewalls and a number of different ways that they can be implemented within your environment. And the runtime protection, similar thing. We protect against the security, privacy, and safety aspects in a similar way that we looked at from a testing point of view. One thing I did want to point out, all of this, we work very closely with OWASP and MITRE. OWASP and MITRE are really driving the standards and the frameworks for responsible and secure AI. And as we do testing and as we get events coming out of our guardrails, we map those back to OWASP. So if we see a prompt injection attack in your event log, you'll see that this violated OWASP LLM01 prompt injections, and then it'll also map to MITRE and the MITRE category that it violated as well. So you have some information as to how the events that are being elicited are aligning to the standards out there in the industry. And so that's pretty much an overview of what we have. Cisco, why are we doing this? Well, we truly feel that to get those policy guardrails and to implement policy in applications and models, our advantage is that we're going to push that into as many different network devices, software, clouds as we possibly can, and implement that policy in a variety of different ways. And then also combining that with our AI threat research team and the testing and the validation tooling that we have, we feel like we have a pretty unique solution. And all of this today supports AWS Bedrock, and we've been working very closely with AWS and appreciate their help on this. So thank you very much.